Hi everybody. Today I am going to show you how to find the wind load on this 10-story office building. Has 6 bay of 7.5 meters in the east-west directions and 3 bay of 6.5 meter. Here you can see that in north-south directions, and all columns are 40 by 40. I mean 400 millimeters by 400 millimeters. And the age of the building extends 200 millimeter beyond the center of exterior column. I mean this from here to here. This is 20 or 200, and here also 200. So ground story, we'll see that in the next slide about the ground story and height of each floor. So let's move in the next slide to see the elevation of the shear wall. So this is the elevation of the shear wall. Here wind load directions are given. As well, it marked as according to the floor. Like at the 3rd floor it is H3, 8th floor it is H8. So this is the wind loads. Now we have to use wind load formula to find the wind load acting at the roof and floor levels. So wind pressure P, here we can see that wind pressure formula, and wind pressure it is here P. This is a specified external pressure acting statically and in a direction normal to the surface. We can see that it is normal to the surface. And to find this, another important things I want to mention, this pressure directed towards the surface, as we can see here, or as a suction directed away from the surface. It happens in the leeward side. So we will use this formula, wind pressure P equal to this. This is IW, importance factor for wind load. For the normal building, we assume it as 1. Then Q. Q actually it is reference velocity pressure by geographic locations. I mean at different places in a country. And This Q, I mean reference velocity pressure for levels of probability having return period of 1 in 50 years. That's what we can see here, 1 in 50 years. So which location our building is, the hourly wind pressure taken as 0.4 kPa. So we will use this value in the next slide for calculating the wind loads. Next is exposure factor. Here I have written exposure factor, it will be 0.9 but greater than or equal to. To find this, we have to use windward wall this formula. HI by 100. It is HI means height of the structure. But one important thing, when we will go for finding this exposure factor for leeward walls, we have to consider at the middle of the height. That is why I have written here HI divided by 2. That will be for the leeward wall for exposure factor. So when we will calculate, we will get these two scenarios. Third is CT, topographical factor. For normal building, it is taken as 1. Because if the building is not located near the hill, so our consideration is normal, so it will be 1. Next is gust factor. Normally for the design of a structural frame, we take gust factor, I mean code NBCC 2015. They consider this gust factor as we are calculating a normal building, so it will be equal to 2. Next is pressure coefficient CP. For windward wall, I mean this one, it will be 0.8. For the leeward wall, it will be minus 0.5. Basically these two values we will use for finding the wind loads CP. So let's move ahead to see how we can use all these factors to fulfill this formula to get the wind loads. Another important thing also, here if we look at all the floor height is 3.5. So 9, 3.5 plus this 4, this is for ground floor, as well this 500 millimeter for the parapet. Total height is 36 meters. In Excel sheet, I am going to calculate the wind loads acting at the roof and floor levels. To do that, I will use wind pressure formula. This one. Already I explained all the factors, what is used in this formula. Regarding this exposure factor value, already I explained that this value will be greater than or equal to 0.9. For the pressure coefficient, for windward wall, it will be 0.8, but for leeward, it will be, here we can see, minus 0.5. Q is 1/50-year wind. It is 0.4 kPa. So here to find the CE, we can use this formula. So let's discuss about this table. I made the table like 9 columns. Already I mentioned here what are the terms to be used for each column. Right here, floor, elevation of floor, windward, this expose factor, I mean this one, exposure factor, CE, and tributary height. Tributary height means, here I have written distance from mid height of the column over the floor to the mid height of the column below the floor. For an example, if I take this H6 floor, 6th floor, then tributary height will be from the lower floor midpoint to the upper floor midpoint. So it will be same as 3.5. That is why I have written here all 3.5. Only roof will be different because there is parapet over the roof. So windward pressure, we have to find windward wind loads, leeward pressure, leeward wind loads, and total wind. Basically, with this table, our target is to find the total wind load on each floor. So let's start how to find a row. So I am considering this row, roof. Height is 35.5. So surely with this formula, I can find windward CE value. It is 1.29. So right away I put here 1.29. I use just Excel how to use the formula. I mean using the cell address. I want to make it slightly bigger. Now it's okay. So we got windward CE. I mean this one, 1.29, using this formula. Now windward side pressure, it is P equal to this formula, wind pressure formula. So we have to put IW, it is 1 importance factor. Topography factor also will be 1. Only CE, Q will be already I mentioned here. We assumed here it is 0.4. Because for each country, for each area, this value is fixed. Different area, there will be different value. For this location where I have selected, this value is 0.4. So here 0.4 value for Q. And CE, already I got here 1.29, and as I told CT, topographic factor, it is 1, and CG, it will be 2, because this is a design of structural frame. That's why I put here 2, and 0.8 already I explained CP. For windward side pressure, CP will be 0.8. So I got 0.825 kPa. Right away I put here 0.825. And this tributary height 2.25. How I got it? It is here, center of this floor, it is half of 3.5 means 1.75, then 0.5, so 2.25 from the midpoint of this floor to the top of the parapet. That's what it is. But for other floor, it will be from the mid to mid, so it will be all 3.5. only this one will be different, because 3.75, because this is 4 meter, this is 3.5. So from this middle to this middle it will be 3.75. So all these values, first one I use the cell address in Excel, so all other value it will be generated according to this formula. Only need to click here and pull it down, automatically all the values will come. So tributary height gone, windward pressure, once I get it using this formula, then once I get it, clicking here, if I pull it down, so it will use this formula. I have kept here formula for this. So automatically all these positions, clicking here, if I pull down, this formula will be used for all these values. You don't need to calculate, automatically throw formula, because formula means I use the cell address. Now windward wind load, how to get that? We got windward pressure. It means once we know the windward pressure, then we have to apply it where this wind pressure is working, I mean on which area. So here you look at 0.825 multiplied by 2.25, we considered it as a tributary height, and 45.4 is the width of the building. So this width multiplied by tributary height, so it will give us the area where this windward pressure is working. So surely we will get the load. So that's what it is, 84.2. So if I click here, this is the things I did. Then again, if you click here, pull it down, all the remaining value will appear. So we got windward wind loads. Now we'll go in the back of the building, I mean leeward wind pressure. We'll use the same formula which we used for windward side pressure. So leeward also will be same. This important factor, topography factor, it will be 1. Only Q also will be 0.4, but this CE it will be different. Before I used 1.29 because here I saw I got it. But when I will go for the leeward wind pressure, this C value, the difference is in the position of HI, I will use half of the height. So for an example, building height is 36, so I will use it like half, like 18 meter. So in that sense, value came 1.125. So I put here 1.125. And this CG, it will be same too, because this is for the design of a structural frame. And regarding this CP, already I mentioned, in case of leeward wind pressure, it will be minus 0.5, but for windward side pressure, it will be 0.8. This is the difference. So results we got minus 0.450 kPa. So right here we can write it here. So once we get this, actually this is the equation, this formula we used. So to do in Excel, I have used the cell address to get all those value. So once I get this, you can see the formula what I used. So once you get this, from clicking here, pull it down, all the value will appear. Then leeward wind load, in the same way, already we know the pressure for leeward, so we have to find the area on which this pressure is working. So it will be 2.25, this is the tributary height, 45.4 is the width of the building, so we get minus 46. So right here you can write this. Now here total wind load, how to get this? So look at Column 6, we got windward wind load, say 84.2. Leeward wind load, we got minus 46. Now, if we subtract this to column value, we will get 130 kilonewton. That's what it is. So once we get this, clicking here, pull it down, you will get this all total wind load for each floor. So this value now we'll bring here, this wind load value we'll bring here in this table. Why? To compute story shears and moments at floor levels. So how to do that? Here I wrote all the floors. This is the story. Story will be middle of this floor and middle of this floor. That's why I put here these red lines to show that it is, see here, 7th floor middle, 6th floor middle. This is 6th story. Now total wind load, this actually we got against the floor. So it is written same as roof 130, 10, 200. It is same as this. I just brought this full column exactly what it is. I brought it here. Now story height. Story height will be 3.5, 3.5, 3.5, all will be like that. And this is story height will be 4. Now story shear. Here also something I have written. 7th story extends from 7th floor to the 8th floor. Shear in 5th story, say I am considering here 5th story shear. If you bring it here, see 5th story shear 1096. How I'll get this? So what I have to take? I have to take 911. This is shear in 6th story plus lateral loads. I mean this one. Lateral loads acting at the 6th floor. This one acting at the 6th floor. You have to come here. 6th floor against 186 and 6th story. Shear in the 6th story, it is 911. So 911 plus 186, we get the shear in the 5th story. So this way we have to calculate all the shears. Now moment, area of the shear force diagram. So how to get 10th floor, say M10, how to find this? Look at here, at 10th floor, say this is wind load, we have say 30. 130 kilonewton multiplied by 3.5. So 330 multiplied by 3.5, we get this 456. Now if we go for the bottom one, then what we will do? We will do the same procedure but previous one to be added. Like 456, this is for M9, lower floor, 9th floor. It will be 456 because we have to find this, how it comes. 456 plus of 330 multiplied by 350. 330 multiplied by 350. Adding this one, we will get this. So if we want to get this one, so we have to take this one and 527 multiplied by 3.5 and plus of 1611, we will get 3455. This way you have to calculate all the values. So at the ground floor, M0 35376, we got same procedure we have to follow to reach up to there. But the question is, this value, it is for two walls, because if we look at here, you can see here two walls, and wind load is acting in this direction for this from here to here, 45.4 width. This is the wind loads acting on these two walls. So what are the value we got? We have to divide it by 2 to get for one shear wall. Same procedure we will follow, right? So I divided it by 2, so 17,688 kilonewton. So factored moment per wall, is it factored? Then we are multiplying it by 1.5. So this multiplied by this, it will be 26532. This kilonewton meter moment on each wall. That's why I wrote here per wall. Here I have showed it. This is shown as a this is the elevation. This wind load 130 to 167, you can look at it is acting on it. This is the wind load. So due to that, this is the shear force diagrams. How it is 130, 330. If you compare this same value 130, 330, 527, 721, so all are the values up to here. Now for this one, this is moment. At the tip, the top, it is 0, then 456, then 1611, then 3455. So this is the diagram for the moment. So we are done to find the wind loads. As I have said, we will find the wind load acting at the roof and the floor level. Here I have mentioned this. As well, we calculated the story shears and moment at floor level. I am going to show you how wind loads and shear and moment diagrams are generated. I mean, how I sketched all this diagram, so you can look at it step by step how I made it. Already we have seen this in Excel sheet. This is the shear diagram. So at an end, VF, kilonewton. Now it is moment diagram. It is exactly the value what we have found as I have shown it in the Excel sheet, that table. So all the values are same as that. So we got here moment, this is shear, and this is the wind load on the shear wall. So here this is the wall. I want to show you that when moment is generated, I mean moment is generated means when I have written the moment per wall, right way I put here, because largest value occur at the base of the wall. So I showed here this MF, I mean this one, per wall. For the shear, also I showed this was for 2 walls, so for per wall it will be 894. So this is VF, that shear. So shear and moment already I calculated from the wind load. But this load, as you can see it here, axial one coming from the vertical load in terms of gravity loads. So these I did not calculate. In my next video I will show it, as well as I will show the load combination also in my next video. Also I will show how to find the length and thickness of the shear wall. I think that's all for this. Thanks for watching.